Hi algebra students, and welcome to our lesson on multiplying and dividing polynomials. At this point in the unit, you know how to add and subtract polynomials. And then yesterday we looked at some exponent rules to help you with today's lesson. Before we get into all the polynomial fun, I've got one review question here for you. The question says graph, and then I'm giving you a linear inequality. Obviously, at home on a computer, you cannot graph yourself, but go ahead and tell me all the steps I would need to graph this. Make sure you don't forget anything because it's not y equals. Go ahead and tell me what I would need to do now. All right, for this problem, we would start off graphing the same way we would if it was an equation. So I would start with my y-intercept at -5. And then because my slope is 3 over 5, that tells me my rise over run. So starting from that y-intercept, I could go up 3 and then over 5 to get a point here. Now I pointed out it's an inequality because with inequalities, there's 2 extra steps. We don't just draw our line and be done with it. The first step is decide if you want a dotted line or a solid line. The way you do that is check to see, does it say or equal to? If it's not or equal to, we should be drawing a dotted line through our points. And then the other step is check for shading. So because this is y is less than tells me I want to shade everything less than my line, which would be everything below the line. So I'm shading down, I'm shading all of that space right there. You are gonna have to check what line you want to use and check for the shading anytime you've got an inequality sign there. So make sure you're on the lookout for that. This was our one review question. Now that we've done that, we can go ahead and get into multiplying and dividing polynomials. Which is what the objective is. I already said it. We're multiplying and dividing polynomials. To start off, I want to start off with a review of something you saw in the lesson video on exponent rules. If you have not already watched that video, stop right here. Make sure you go watch it because we're going to be using a lot of the stuff we learned in that video to help us with today's lesson. In that lesson, we learned that when you multiply polynomials, what do you do with those exponents? We learned that when you're multiplying, you want to add the exponents. That is going to help us to do some of our problems today. In yesterday's lesson, all of our problems were monomials, meaning I was multiplying one term by one term. What we're looking at today, is a little different because I'm multiplying one term, a monomial, by a polynomial. I'm multiplying one term by 1, 2, 3 terms. The idea is the same as what we did yesterday. We're just going to have to do an extra step because if I wanted to multiply 6x by this polynomial, I'm going to have to distribute. I'm going to have to multiply 6x times 2x squared, 6x times 3x, and 6x times the -2. So it's like doing 3 of the problems we did yesterday. When I go to do this, I'm going to keep in mind that rule we had, that when you're multiplying, you add your exponents. So for this first one here, the 6x times 2x squared, I like to break it up into parts. So I would start off by saying, well, 6 times 2, that gives me 12. And then when I multiply my x's, I know I want to add those exponents. The exponent here, I don't see it, but it's the exponent 1. So if I add 1 plus 2, that gives me x cubed. That 3 just means we're multiplying 3 x's altogether. What about this next one? 6x times 3x? Same idea. 6 times 3 gives me 18. And then x times x, that's usually one of the ones students make mistakes on. They want to say x times x is x. X times x is x squared. That's literally what x squared means, right? Is x times x. But you can also go back to that rule and say if you add those exponents, 1 plus 1 gives you 2. There's one last part, the 6x times that -2. Well, 6 times -2 gives me a -12 or -12. And then I've got an x here. I've got nothing to multiply it with, so all I've got to do is copy it down. We get the -12x. I could check this to see if there's anything else I can do. What do you think? Well, I see that all of my exponents are different. We had learned back in adding and subtracting polynomials that you can only combine them if they're the same. So because of all of those exponents being different, there's nothing else I can do. I can't add or subtract anything together. This right here is my final answer. I've got one last one here. The idea is the same as that first one. I'm going to take that term outside our parentheses, and I want to distribute it to everything inside. Just be careful with that negative sign. Make sure you're paying attention to the signs of what you get when you multiply. So for this first part, negative 7y times y squared. Well, negative 7y, there's no number for me to multiply it with, so I'm just going to say negative 7. You could also say negative 7 times 1 and get negative 7 that way. And then the y times y squared, well, that's easy. Y cubed, because 1 plus 2 gives me 3. The next part, the negative 7y times 3xy, there's a little more going on there. What's that going to give us? Well, the negative 7 times 3 gives me negative 21. Notice I'm not copying down that plus sign there. I'm not doing that because I've got a negative times a positive. So it's giving me that minus sign. When I go to multiply my variables, I see there's two y's for me to multiply together. So I can say y times y gives me y squared. And then there's an x here. There's no other x's for me to multiply it with, so I can bring it down. Now, one way you could write that term is negative 21 y squared x. There's another way you can write it. Do you know what that other way is? Well, those variables, it doesn't matter the order you put them in. So I could write it like this. Someone else might have said, well, let me copy down that x first and then multiply our y's together to get y squared. Both of these are okay. Notice that both of them have that number, that coefficient in front. That is important. That one has to come in front. But the order of your variables doesn't matter. It's whatever your heart desires. The last part there, the negative 7y times that negative 4. Well, first thing I see is negative times negative gives me positive. And then I could say 7 times 4, 28. Don't forget about that y. We want to copy that down. And then just like before, all of our exponents here are different, so there's nothing I can combine. This is my final answer. These were my two examples I've got. I'm going to erase all of this so you can try your two practice problems. The first one looks pretty similar to what we were just doing. It says negative 4a times 3a squared plus 5ab minus 2b squared. The second one says find the area. I'm giving you a rectangle. One side says 5x and the other side says 5x minus 4. Find the area. Well, do we remember what area is? We've looked at some perimeter problems with polynomials, but no area problems yet. If you are finding the area of something, that is how much space is inside the shape. And to find area of a rectangle, we're using the formula area equals length times width. So if I want to find the area of this, that means I want to multiply my two sides together. Doesn't matter how you write that. So sometimes people write it as 5x minus 4 times 5x, and that's totally fine. To make it look similar to what you already were looking at, I'm just going to put that monomial in front, and then the 5x minus 4 second. Now it looks kind of like what you've already done. Both of these say the same thing, though. Here I would start by doing 5x times 5x, which gives me 25x squared. If you wrote it like this, it's the same idea. We're taking 5x times 5x, getting 25x squared. And then the second part, the 5x times that minus 4, that gives me minus 20x. Same idea here, the negative 4 times the 5x gives me negative 20x. The one thing that both of these have in common is notice those parentheses. I need those there so that it's saying I'm multiplying this side by this entire side. Not just 5x times 5x, but 5x times 5x and 5x times the minus 4. So we'll get our answer of 25x squared minus 20x, no matter how you write it. Now, what all of these problems had in common is I was taking a monomial, one term, and multiplying it by a polynomial. Lots of terms. The other multiplication problems we're going to see together are these problems here, where we're multiplying binomials. Do you remember what binomials are? By 2. They're going to be polynomials with 2 terms. So the first example I've got is this one right here. This says x minus 1, that's our first binomial. And I'm multiplying it by our second binomial, which is x plus 3. Now to do this multiplication problem, it's actually pretty similar with what we were doing before. All we need is distribution. What I'm going to do is I'm going to pretend that minus 1 isn't there for a second and just focus in on the x times x plus 3. If I want to do that, just like we were doing before, I'm going to distribute. I'm going to take x times x and x times 3. When I do that, x times x gives me x squared, and then x times 3 is going to give me 3x. Now that's the first part of the problem. That's not the entire problem though, because remember it's not just x times x plus 3, there's also that minus 1 there. So we're going to do the same thing, except now I'm going to pretend x isn't there and focus in on that minus 1, that negative 1. Let's distribute that now. I've got my minus 1 times x and minus 1 times 3. When I do that, the negative 1 times x gives me negative 1x, which I'm just going to write as negative x, since we don't need that 1 there. And then the negative 1 times 3, well, negative 1 times 3 gives me negative 3. Notice when I do that, I'm taking 2 terms times 2 terms, and I'm getting 1, 2, 3, 4 terms. Just saying 2 times 2 should give you 4. Now here, I've got everything that's been multiplied out, but there's still more I can do. Do you see what we can do next to get our final answer? Well, unlike all those past problems we were looking at, if I look at these 4 terms, we have like terms. There are 2 things here we can combine, and that is our 3x and our minus x. Those are like terms because they both have the same variable and the same exponent. So I can go ahead and finish simplifying this by copying down my x squared and then saying 3x minus x gives me 2x, and then the last part, that minus 3. This right here would be our final answer. Now this is one example of multiplying binomials. Over here I've got our second example. Now this one says, all in parentheses, 2m plus 3p, that's our binomial there, and we've got it squared. Now when it comes to squaring things, there's something we looked at yesterday. When I was asking you, well, what does it mean to square stuff? I made like a list of quick problems. Remember how I said, well, what's 5 squared? And you all at home, of course, told me 5 times 5. I asked you what x squared is, and you said x times x. I asked you what smiley face squared is, and you laughed at my funny jokes, and you told me it's smiley face times smiley face. Well, I'm reviewing this because here it's the same idea. I am taking a binomial and squaring it. What does that mean when you square something? Well, if you square something, you are multiplying it by itself. What 2m plus 3p altogether squared means is I am taking this binomial and multiplying it by itself. I am taking 2m plus 3p and I'm multiplying it by itself. Now it's really important that we know that's what it means, because the biggest mistake students make is they see this problem and they say, okay, I want to do 2m squared, so 2m times 2m, and I want to do 3p squared, so 3p times 3p. If you're thinking like that, you're missing some of the terms. This right here, when I multiply it out, is going to look like this. There's going to be 4 terms in our answer, and you're not going to see all 4 of those terms unless you're thinking 2m plus 3p times 2m plus 3p. So writing it like this will be my first step. Once I've got it like that, now all I have to do is multiply, just like we did before. The first thing I'm going to do is take my 2m and distribute that. What should I get when I do that? Well, when I distribute 2m times 2m gives me 4m squared. And then the 2m times 3p, well, 2 times 3 gives me 6, so I've got a plus 6 there. I don't care if you wrote mp, if you wrote pm. It doesn't matter the order of the variables, but we need both of them. So I need an m and a p. Now that's the first part of multiplying this out. What's the second part going to be? Well, I want to take my 3p and do the same thing. I'm going to take 3p and do 3p times 2m and 3p times 3p. 3p times 2m, it's the same thing I just did. I get 6mp. Again, it doesn't matter the order you write those variables, but I am, for my sake, going to write them the same way I did here, in the same order. And then the last part, the 3p times 3p, well, I know 3 times 3 gives me 9, and p times p gives me p squared. Remember we said we want 4 terms if we're multiplying all that out, and here are my 4 terms. Is that my final answer? No, just like over there, there's 2 terms there we can combine. I've got the plus 6p, the 6mp plus 6mp. When you combine those, 6 and 6 is going to give you 12, so you're left with 12mp. And then I've still got my 4m squared and my plus 9p squared. I didn't mention it earlier, but I'm going to mention it here. When you are combining like terms, remember combining like terms, you only add those coefficients. You only add the numbers. The variables you copy down. We've been doing a lot of stuff with exponents and changing exponents, adding exponents, subtracting exponents, all sorts of stuff. Remember, when you are adding and subtracting, when you're combining things, those exponents stay the same. I'm not adding exponents, I'm not subtracting exponents, I'm not doing crazy things to the exponents. When you're combining things, keep those variables exactly as they are. That's another common mistake I see. These were the 2 examples I had for me. Now I've got 2 for you, except I made yours way more fun. Here is the first one. This first one here says 2y squared plus 3y minus 8 times y plus 1 minus 4. Go ahead and simplify that as much as you can. Like I said, I gave you guys the fun one to try. Where would you want to start in this problem? Well, I see some addition here, I see some subtraction here, and all of this is multiplication. We need to start with that multiplication. If you didn't know where to start, go ahead and pause the video now and try it yourself. This right here is where you want to begin though. We want to multiply all of this out, then we can worry about adding the 2y squared and subtracting the 4. When you multiply all of that out, this 2y squared is still there. And when you multiply this, you get 3y squared plus 3y minus 8y minus 8. And then I'm going to copy that minus 4 down. Normally, when we're multiplying, we've got 4 terms, which I have those 4 terms there. But I copied down another 2 terms. I copied down the 2y squared, and I copied down the minus 4. So there's a lot of stuff here. The next part is checking to see what you can combine. Well, I see I've got a 2y squared and a 3y squared, so I can go ahead and combine those and get 5y squared. I also see I've got a 3y and a minus 8y. I can combine those and get minus 5y. And then the last part, I've got 2 numbers. I've got a minus 8 and a minus 4, so I can combine those and get minus 12. So our final answer, we've got 5y squared minus 5y minus 12. I said I had 2 for you to try. That was the first one. The second one is another fun one. This second one here says, which of the following expressions are trinomials? Do you remember what a trinomial is? Tri, 3. Think triangle, tricycle. A trinomial means there's 3 terms. So which of the following expressions are trinomials? And I'm giving you a clue. Aren't I so kind? It says there may be more than one correct answer. There is more than one correct answer. Looking at these problems here, in class, students so badly want to just like look at them and be, okay, it's these. You cannot know if they're a trinomial unless you simplify them. So in order to answer this question, you're going to have to do some math. you're going to have to see if once you've done all the math there is to do, once you've simplified it as much as you can, is it a trinomial? Go ahead and try this now. Well, here, when we multiply this first one, you are going to want to start by doing x minus 4 times x minus 4. When you multiply all that out, it's going to give you x squared minus 8x plus 16. So this is one of your trinomials. The second one here, it's so tempting to say, yes, that's a trinomial because we've got 1, 2, 3 terms. But when you simplify it, x plus x plus x equals 3x. That is not a trinomial. That is a monomial. There's only one term. This one here, when you multiply it out, it's tempting to say, it's going to look similar to this. There's going to be 3 terms. But if you multiply it out, you get 4x squared minus 2x plus 2x minus 1. Those x's in the middle are going to cancel, which means you're just left with 4x squared minus 1. Not a trinomial. That's a binomial. There's 2 terms. So not this one. I'm very tempted to say this last one because I told you there's more than one, but we should do the math too. When you do the math, you're going to get 20x to the 4th power plus 8x cubed minus 16x squared. There's nothing to combine because all those exponents are different. And look, there is 1, 2, 3 terms. So that was our other trinomial. So to answer this question, which of the following are trinomials? We would have said option A and option D. I love this question. Look how much math you get to do to answer the question. So fun, right? All of these problems here, we're practicing multiplying polynomials. The last part of this lesson is on dividing polynomials. Before we get into any division problems, a quick reminder, in that lesson on exponent rules, we learned that when you divide polynomials, what do you do with those exponents? We learned that with division problems, you want to subtract those exponents. So keeping that in mind, I've got these 2 problems here. This first problem, notice the use of parentheses. They've got parentheses around this binomial. What that means is we're taking this binomial and dividing the entire thing by 8x. Oftentimes what helps students with these is rewriting it to look more like a fraction. What this is really saying is 16x plus 24xy, we are dividing all of that by 8x. You can write it like this, or if you want, you can show each one individually being divided. So what that means is I'm going to divide 16x by 8x, and I'm also going to divide 24xy by 8x. In order to do this, it's really just like what we were doing yesterday in exponent rules. We're just doing it twice. So for this first one, 16x divided by 8x, well, I like to break it up into parts, remember? So I'll say 16 divided by 8. I know that's 2. And then I see x divided by x. That was one of our rules we learned yesterday. Anytime you're dividing something by itself, those cancel out, equals 1. So really this is just saying 2 times 1 or 2. So this first part gives me 2. What about the second part? Well, 24 divided by 8, I know that's 3. And then again, I see x divided by x. Those x's are going to cancel out. There's a y here that I'm not dividing anything else with, so I'm just going to copy down that y and say 3y. Our final answer, 2 plus 3y. This one here is real similar. Go ahead and try this one. For that problem there, when you take your 25st and divide by 5s, 25 divided by 5 gives you 5. Those s's will cancel out, and you'll just have your t left. And then for the second part, 35 divided by 5 gives you 7. Those s's cancel out, so it's just minus 7. These here had smaller exponents, less terms, not too bad. We're going to make these problems a little more fun by giving you more stuff going on in them. So for this question here, it's telling us the area of a rectangle is this fun-looking polynomial. And the question is, what polynomial represents the length of the missing side? So we've got the area of the rectangle here. I'm giving you one side of the rectangle, and we're trying to figure out what the other side is. Now, if I come back to the question, notice the question is talking about area. I gave you a question about area earlier on. What do you remember about finding area? Well, to find the area of a rectangle, area equals length times width. So what this problem is telling me is I know one side is 8x squared. I don't know what the other side is, but area is length times width. So I know that if I multiply this side times this side, it's going to give me this as the area. One way you can figure this out is by saying exactly that. You can say, well, what do I have to multiply 8x squared by to get this? But there's another way you can think of it. Instead of having my formula solved for area, we could go back to what we know about literal equations, solving equations that look like that. And instead of solving for area, I'm trying to find the length. Let's change the formula to look like length. I've got my area equals length times width. If I wanted to say length equals, if I want to get length by itself, I need to get rid of width. So instead of multiplying by width, I'm going to do the opposite. I'm going to divide by width. And if I do that, that tells me the length equals the area divided by the width. Now, what does that tell me? Well, it tells me to figure out this missing length here, I need to take my area divided by the width of the rectangle. You might have already known to do that without this, but I could not possibly miss an opportunity to show off something we learned earlier in this class on literal equations. The punchline, though, is to get our answer, to figure out that length here, I need to take this polynomial and divide it by the 8x squared. So I'm going to need to do 16x cubed plus 4x to the 5th power minus 8x squared, all divided by 8x squared. One way you can look at it is like I just wrote. Another way that I see helps students a lot of times is writing it as 3 division problems. So I'm going to break it up a little bit like that. You might be able to write it a little neater. When I look at it this way, though, it's telling me exactly what I want to do. I want to divide these two, I want to divide these two, and then divide these last two. For the first part, the 16x cubed divided by 8x squared, what's that going to give me? Well, 16 divided by 8 gives me 2. And then x cubed divided by x squared, I am dividing. We just said earlier when you're dividing and the base is the same, you want to subtract those exponents. So I'm going to say 3 minus 2 gives me 1. So I want x to the first power, but I don't need to write that 1 because you don't write the exponent when it's 1. That's what I get from the first division problem. For the second one, we've got 4x to the 5th power divided by 8x squared. What is that part they're going to give me? Now this one can be a little tricky because notice I've got 4 divided by 8. 4 divided by 8 is different than these other division problems we've done, because if you have 4, you can't divide it by 8 and get a whole number. 4 divided by 8 is actually a fraction. I can write a fraction here for my coefficient. That's fine. I'm going to simplify it first, though. I'm going to say, well, both of those I can divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So I get 1/2. So this term here is going to start off with 1/2. And then when I divide my x's, I subtract my exponents and get x cubed. Now this last part says 8x squared divided by 8x squared. So often students want to come in and say, it cancels out, we're done. Yes, it cancels out, but when something cancels out, what does that mean? What does 8 divided by 8 give you? What does x squared divided by x squared give you? Gives you 1. So we're not just going to cross them off and be done with it. 8x squared divided by 8x squared gives us 1, so I need to write minus 1. And so with that, we have got our polynomial. That missing side right here is 2x plus 1/2 x cubed minus 1. Now that is the answer, but I have a question to ask you, a bonus question. What could we do to check that answer? Well, remember what this problem's talking about. It's talking about area. So it's telling me this is the area. I could check by making sure that our length times our width gives us that area. So I could check by making sure that 8x squared times 2x plus 1/2 x cubed minus 1. I could check to make sure that when I multiply that, I get the area. I've already got it written, so let's go ahead and try. If I multiply these together, well, 8 times 2 gives me 16, and then x squared times x. We're multiplying, so I am adding those exponents and getting x cubed. This next one here might look a little tricky because we have to do 8 times 1/2, but remember multiplying by a half is just taking half of that number. So 8 times 1/2 is the same thing as half of 8, which is 4. And then for my x's, I'm adding those exponents. Then one last time, 8x squared times minus 1. Well, that one's pretty easy. Anytime you're multiplying by 1, it's itself. So we get minus 8x squared. And let me check. Oh, look, they're the same. That helps me know that I have found the correct missing side. This was my last example. I have got this last problem here for you to try, and then that will be the end of this. Your question says, divide 18a to the 4th power minus 3a cubed plus 12a. Divide all of that by 6a. Go ahead and try that now. Well, if we do that, 18a to the 4th power divided by 6a gives you 3a cubed. The minus 3a cubed divided by 6a, that's the one you want to be careful with. 3 over 6 is a fraction. That simplifies to 1/2. So we get 1/2 a squared. And then the last part, the 12a divided by 6a, that just gives you 2. Those a's cancel out. Thank you so much for watching this lesson on multiplying and dividing polynomials. Guess what, guys? There's only one lesson left, and that will be what you guys are seeing tomorrow. So get excited. Bye, guys.